Okay. Welcome back, everyone. This is our morning lecture on Friday, week 1, day 5. We're going to cover our JavaScript material. Since we mostly covered it already in programming basics, I will try to gloss over the stuff we would have already understood, already would have covered, and skip ahead to stuff that would be challenging. Okay. So let's just make sure we have a full understanding of JavaScript and that no stone is unturned here. Okay, we know what variables are, right? They're containers for values. All right, so this should be no problem to understand all this information here, how to create a variable and how to put information in that variable, the different data types that we have. We have strings, we have numbers, we have booleans, and we have the rest, null, undefined, all the values that are non-values. Okay, we have the operators that we know I've been working with: subtract, add, multiply, divide, and we know the order of operations, right? So anything within parentheses is handled first, then exponents, then multiplication, and then division, and then addition, subtraction. We know what primitive data types are. Who can tell me off the top of their head what's a primitive data type? How is it different than other types of data? You should remember this from last week. Should be a quick answer. And we're staring right at it, so someone tell me.
Does it?
String.
Okay, yeah, so what's primitive? Why is it primitive compared to an array or object, which is not primitive?
It just it's exactly what it says. It just stores a random piece of information. It's not any more complicated than that. It just stores like a number 1 or a string.
Right, so a number, whenever we think of a number or string or Boolean, a number is just going to be a number, 1 through however many numbers there are, or any type of integer is going to be a number. No letter is going to be considered a number. A string would be anything within quotes, right? It doesn't matter if it's a number or a letter. If it's within a string, it's within quotes, it's a string. All right, doesn't matter what type of value it is. And a Boolean is either going to be true or false. So those are simple. Those are not complex. They're not mixed data types. Like an array can be numbers, strings. It can be a combination of Boolean values too. So these are non-primitive because they can carry different types of data. They're not simple, right? These are simple. These are simple data types. What's a string is anything in quotes. What's a number is anything that's a number, true or false. Those are the only values you can have for Boolean. But an array can have all those values mixed up. Okay, I believe we should already understand this, but if we don't, let's take a poll to make sure that this is still within our frame of understanding. And for some reason, the poll just disappeared on me. Oh, here it is. All right. Do we understand primitive versus non-primitive data types? All right, so let's continue. We know what conditional statements are. We said the two pillars of programming were if statements and for loops, right? So conditionals are also in the forms of operators. Is not equal to B, so it's checking something, it's asking a question. Is A equal to B? If true, then this will result in a true Boolean statement. Conditional statements are if statements. If else if, and else statements. We already know what these are. Okay, so I just want to gloss over and say this is what we would have covered had we not done programming basics. We know what the modulo operator is. It divides something and tells us the remainder. So that's how we can check if something is even or odd. Okay, imagine if we were just learning this all in one day today, instead of having the practice of programming basics. Okay, so one thing that now we can read up on to have a better understanding is strict equality versus non-strict. There's a difference between a triple equal sign and a double equal sign. Can anyone tell me the difference before I explain it? Yeah.
One is one is equality and one is like strictness or truth and false.
One is strict equality and one is loose. Okay, what do we mean by that? There's now going to be what's called truth E and false E statements. Okay, they're truth-like statements and false-like statements. So any values that are truthy are values except these values. These are the falsy ones. False, 0, -0, empty quotations, null, undefined. Not NaN stands for not a number. So all these values, they're not exactly just false, but they're false-like. They're like a negative value. You know how like sometimes we just say, oh, that's like a negative thing. It's not like it's actually subtracting something, but it's in a way it does vacuum energy. So this is like a untrue like. So let's give some example. I think I have to pull up Visual Studio Code to show what I mean. So I will create a file called index.js. Script.js. And this is where we'll work for just a moment. So if I say if if 0 is equal to false, console.log falsy. So we said this was a false E statement, right? False E. So it's false like. And we said 0 is also a false like. So this double equal sign is comparing. Are these both falsy values? So if we run this, we get the output falsy. So 0 is equal to false when we're asking, is it equal to false in a non-strict way? In a non-strict way. But if we add the triple equal sign, now it's checking for a hard check. If on the other side of this equal sign, we don't have something that's equal to 0, then we're not going to get our falsy, right? So we'll write an else. So we'll say else console.log not a falsy. Okay. And when we run the triple equal sign, we're asking, is 0 equal to false in the hard sense? In a strict sense? No. 0 is not equal to false in the strict sense. But in a loose sense, yes, they're both false E. So then we console log and we get false E. I want to check with you guys to see how much this is making sense for now.
So basically 3 equal signs means it's absolute.
Absolutely. We're asking in a strict sense, is 0 equal to false? No, not in a strict sense, but in a loose comparison sense. So double equal is a loose equality, triple equal is a strict. It has to be exactly that thing.
Okay.
So these are falsy type of statements: null, undefined, NaN, 0. So let's ask if NaN is loosely equal to undefined. Is NaN not a number? Is it loosely equal to undefined? And we should get a log, right? Let's see it. Oh, actually, it's not. Did we write that correctly? So NaN is not loosely equal to undefined. Not a falsie. What about if NaN is equal to 0? No, it's not. NaN stands for not a number. Let's change NaN to false. And let's change this to undefined. Is false equal to undefined? Is false equal to undefined in the loose sense? No, false is not equal to undefined in the loose sense. We have to make it something like 0, I think. Okay, let's run this. This one's not a falsie. So what are we doing different? I thought it would let's see, null. Is 0 loosely equal to null? Not a falsie. What about an empty string? This one is a falsie. 0 is empty in a loose, non-strict sense. 0 is equal to an empty string. If we add a triple equal sign, then this will trigger our not a falsie. There we are, not a falsie. So we have to make it a double equal sign to equal. So have this in mind. If you're coding in the future and it needs to be a strict equality, then you do a triple equal sign. All right, this is something to gain practice with, understanding as you practice with it, just like you saw me do. Take different values, create an if-else statement, and see if you can get an understanding by testing the different values together. Okay, practice is the best way to make yourself understand something. Okay, so now we get to touch on things like this because we had already covered all this material in programming basics. So let's continue. We mostly know about for loops. There's nothing here, I think, that would not have been covered in our first week. And we also did while loops yesterday morning. So we have a pretty good understanding of that. So we're clearing through today's material. All right, there's some practice assignments that you can work on today. This is a JavaScript day. The first one is FizzBuzz. So we want to write a function that if the number is a multiple of 3, print fizz. And for each number that's a multiple of 5, print buzz. And for numbers that are multiple of 3 and 5, we want to print fizz buzz. This assignment here, I've seen multiple times as coding interview questions for a job, fizz buzz specifically. Okay, so practice this assignment. This is going to, you don't have to memorize how to do this for an interview, but as long as you know that you did it once, then you can figure it out again later on if you encounter it. Okay, so fizz buzz. Let's go over our code here that says that debugging. This is just a little poem here with the video, so there's nothing really to show for this one. When it comes to debugging our code, I've seen most of us use this little play button here, run and debug, to show our index.html. This here on Visual Studio Code is used to run and debug JavaScript, and you'll be using this more often in the MERN stack. You'll be running JavaScript code more often, so you don't have to use this yet. The only way we can debug for now is going to be through a console log. Console log is going to show us where we are in our code, what we need to do to make it work properly. So for now, when we need to debug something, console log's our best friend. Okay, I'm not taking polls because I'm sure we understand this already. Let's fully expand this here. Okay, arrays and functions. I think we pretty much covered everything related to arrays or functions. Okay, so we have a copy of an array here. We know that an array is a non-primitive data type. There's nothing here we need to cover. So let's continue. I think we can skip functions as well. We know how to create a function, how to call a function, how to start a function, right? This is a function defined, for loop within it. If we wanted to call this function to make it start, we have to have this written somewhere, counter parentheses to make it start. This is the invocation, right? We should know this already.
Can you just run through that one more time? When I was going through the rooms, I know some people would just, like, syntax wise wasn't there, so
Okay.
just go
Good.
through it real quick.
All right, good point, Vincent. Okay, so when we see a function, this is a function defined. Let me format document. This is a function, this here. So let me just indent a little bit so I can draw on the screen just a little bit. Every function needs this keyword function. All right, that's how we get a function defined and started. It needs the keyword function. Each function needs to start with the word function, and then we also have the name. The name of the function is vital, super important. Each function needs a name. Okay, so this is the function name. And this parentheses area is where we can insert values. We can insert values and have some placeholders for some values that we would receive, okay? This is the parameters. Let me draw an arrow to this. This is the parameters. All right, and then we have here the do something section. this here is the do something section. I'm gonna make it blue. Everything within this curly bracket here and this curly bracket here, everything within there is the area where we write our logic. Okay, call this is where we want the logic to do something specifically. In this case, we said run a for loop. So whenever I call it the do something section, I mean, this is the place where we write our logic. Okay. And I can't delete this here, so just ignore this little thing here. All right, so we have our function. Our function is not going to be called, though. It's not going to actually run this function unless it's invoked, unless it's called. So let's clear the drawings. I'll delete this. And if I click run, right, it's going to run everything on this page. So including everything here. This is all going to run if I click this play button. So let's click the play button. Let's clear it. And it finished running. It did everything on this page. It read this function, it understood it, but it didn't start the function. The reason it didn't start the function is because we didn't have a function invocation. We didn't have a function start. The way we write our function, the way we write the start button for our function is taking the name and the parentheses alongside it. So now with line 15, if we run our code, it should actually start it. Okay, this is the way we start our function, by writing the name of the function and having a parentheses, open and close parentheses. By calling this, it now will actually do everything in here. Okay, so now I'll press play. And now it will console log 0 through 5. Right? Because that's our for loop. Our for loop is inside our function. Our function will activate as soon as somewhere on the code this is invoked. This is written. This is the start button to our function. Let's do a poll check for this one. How well do we understand this? Because I did notice that we were struggling with this during our morning algo as well. Without line 15, our function will not start. All right, let's run it again. I'm going to delete line 15. Okay, no start button. I'm going to run the code. It finishes executing. Nothing is printed to the console because the function was acknowledged, but it wasn't actually started. Okay.
Can you try invoking it without the parentheses as well, so we can see that?
Good idea. All right, so now I'm going to run the name of the function without parentheses. No parentheses. Just the name. I have the start button. It's half baked. It doesn't have the parentheses. And as you can see here, when I run my code, same thing happens. Nothing happens. So in order to get the full start button, let's put the parentheses back. This is now saying, I want you to run wherever this function exists. I want you to run it. Okay, and the computer remembers. Okay, I remember this function being defined from 1 to 12. So I will go ahead and run this now. So it goes inside, it runs the for loop, it knows it has the console log, so it'll console log. What if I say now, I'm going to make a variable to equal this? var hello, function is called hello. What if I run my code now? What do we expect to happen?
Still nothing.
Still nothing. Why?
Because we ain't called the function yet.
Okay, but what I thought the start button was written right here.
There's no argument.
Oh, it does run it.
Okay. So let's see that again. All right. So now we have the function call. It's attached to a variable. And it still runs. Function call is still legitimate, even though it's packed inside this box. So it will still run if it reads it somewhere like this, somewhere on the page.
So we just otherwise haven't done anything with that new variable.
We just haven't done anything with this variable, right? We haven't used this variable other than here it is. It's the variable that holds the function call.
So it'll work with or without the variable.
Right. As you
Okay.
can see here, the console log still ran.
Can you show it if it has a return?
Yep. Okay. So let's delete our start button. And I'm gonna write a return. I'm gonna just return the string Happy Friday. Okay. No start button. Let's run the function. Oh, let's delete. Okay, fresh start. Let's run the function now. It finished. Nothing ran. It acknowledged its existence, but it did not start it. Okay, now let's run. Let's start our function. So I write the name and I put parentheses. What happens when I return Happy Friday? We still only see 0 through 5. So how can we see this return? Why didn't we see it when we ran our function? Can someone tell me?
Because you didn't console log it.
Okay. Why do I need to console log it to see this value return?
Doesn't return just stop it where it is at that point, and console log is the actual thing that prints out
Okay.
what I'm trying to say.
Yes, you're right. Return stops. Return stops the function. But what about this? I wanted my function. I wanted my function to have this value of this string, Happy Friday. So how come I didn't see Happy Friday anywhere in here? What's the difference between return and console log?
Return stores the value.
Return stores the value. It stores the value somewhere. Where does it store the value to?
The function.
Yes. So when we see return, when we see a return like this, we should think, okay, T diagram. When we see a return, it's as if we saw a variable with a value. Now our variable is counter. We're going to write this as if we saw a variable counter. And what's the value? The value is going to be Happy Friday. So whenever we see a return, treat it as if you are writing a variable with a value on a T diagram for this function. So return is going to assign the value of Happy Friday, this string here. It's going to assign it to this, what we're going to call it like a variable counter. So how then can we see Happy Friday? Now that I gave this clue, how can we see Happy Friday?
We need an if statement.
No, not exactly.
Can you just say console log counter?
Right. If we console log counter, we are console logging this value right here. We're console logging Happy Friday if we console log counter. So now let's console log counter. Let's console log this and see what happens. We get 1 through 5, and then at the very end, now we get Happy Friday. Console log is always just going to print to this console area. It's always just going to print to this console area when we tell it to. So when we ran this function, here's the function call. The function ran, but we also logged the value of this specific function. And the value of this specific function from this console log, we said was going to be the return. So return gets assigned to here. And when we console log this, we are getting its return.
So do we not have to put parentheses for the return statements?
No, return statements, whatever you return, it just comes in a space right after the return.
Okay.
Okay, how well do we understand the difference between a console log and a return, and how to console log the return value? What you guys need to do to understand that are not putting 10s in this poll is to create a JavaScript document and just play with it as you see me doing in this lecture. And I can tell you this from like personal testimony myself. I didn't get this until I just, I myself wouldn't understand JavaScript had I not built the functions and then try to console log, okay, what do I get here in the console when I do it without a console log? What do I do with a console log, with a return or without a return? It didn't click in my head until I built the code and started playing with it. You can watch someone else do it, right? Like you can watch Jimi Hendrix play the guitar, for years, but you're not going to be able to play it unless you practice yourself. You're not going to have that firsthand experience knowledge unless you build a function and then console log with the return and console log without a return. Okay, I would do something like this, for example. What if we console log after our return? What if we console log happy weekend? All right. Are we going to see this printed to the console? Let's see. Nope, we didn't see it. Why not?
It's not defined.
No, we already did the return function.
What happens is as soon as we hit this return, it exits the function and gives that value to the function. And so everything after the return is not going to be read. That's why it's kind of grayed out. If you can tell the difference between this console log, which is white, and this one is a little bit grayed out. This one is saying you declared it, but it's never going to get read. It's not going to get used. That's because it comes after the return. The return exits the function. Okay, if I write it before the return, now you see it's white. It's going to get triggered. So if I click play now, you'll see the difference. 1, 2, 3, 4, 5. Then we console log Then we do the last thing in the function. The return, anytime you hit a return in your function, it should be the last thing you do in your function. Okay, let's take another poll. How well do we understand that that's how the return works? As soon as you hit the return, you finish. Nothing after is going to get run. Okay, and I'll have this code available on the GitHub if you want to tinker with it yourself. I highly recommend it. You also can just build your own function and tinker with it, just as you saw me do. Okay, you no longer need trace. You don't need a Python tutor. You can just build the code on a JS file, console log it anytime you make a slight difference. Okay, now we won't get happy weekend if I console log. Okay.
So when you say that anything that's after return won't be recognized in the console log, does that apply to the other console log that has counter into it because it's not inside the brackets or the curly brackets?
Well, this here is outside of our function, right? So this
Right.
function begins on line 4 and ends on 14. So the return only applies when it's within the function.
Okay.
Okay. This is going to run just fine because it's outside of our function. So
Okay.
let me give an analogy. All right. This is the recipe in the cookbook. The recipe exists in the cookbook. It has everything defined for how to make the great, gumbo soup. All right. The best gumbo soup recipe is here. But no one, just because it's written down doesn't mean it's going to cook itself. Just because it's defined somewhere doesn't mean it's just going to make itself run. There has to be some sort of switch to make it run outside of itself. That's what this is. Okay, this is the on switch. The name of the function, when you see the name of the function with the parentheses right after it, that's the starting of the function. That means let's start this thing. Let's actually cook what the recipe says to do. Does that make a little more sense?
Yeah, it does. So basically counter is, I don't know, the oven, I guess.
This is the start button, right? This is like all the food here is in the oven. Oven is ready to go, but no, it's not going to start itself. It has to have something outside of itself that says, this means start.
Understood.
Okay. This is like the Harry Potter analogy. This is the spell in the spell book. This is the waving of the wand. Okay. This is the abracadabra. Just because, it's defined somewhere in a book doesn't mean it's actually going to be done. Someone has to say, start this thing. All right. Tinker with it. By tinker, I mean play with the code, delete a little bit, run it again, add a little more, run it again, see how it changes. All right, let's go back to our lesson. All right, so here's the invoking or the calling of the function. So how many times is this function going to run here?
Twice.
Twice. Why?
Calling counter twice.
Right, 2 start buttons, right?
Yeah.
We said start it again. Anytime we see this written, that means run the function. If we saw this a third time, this function would read 3 times. It would run the function 3 times. This is the computer. It exists. It has all that it needs to start. This is the power button. Okay. Now we have parameters as well. Parameters are those placeholders in that parentheses area. They receive the values that we put in when we call the function. All right, so if a function has something like this, that means it needs to receive a value. So when we call the function, we have to put some value in the parentheses there. All right, let's take this here. Let's take this and let's comment out everything we have here. We don't need this anymore. Let's move down. Now here's our code that we're going to look at. Let's delete all this. What's going to happen if I call my function excuse me. What's going to happen if I call the function like this? What do we expect to see now? What's going to happen? The function is expecting some parameter in order to run, right? So here's the placeholder. It's ready to receive something. And nothing is passed in. So what happens? Nothing. You see, the code just finished running. And because I didn't give it a value, it didn't do anything. Let's run it again to see. It finished. It finished and nothing happened. So whenever a function is defined and it has a parameter, that's that placeholder here, we have to give it what's called an argument. An argument is a value that's passed into that parameter. So let's give it a number now. Let's give it 2. Now we give it 2. This receives that 2. And then it passes it to anywhere it's used in the function. So whenever we see start num in the function now, its value is going to be 2 that we passed in originally. So now let's run this. 210. The function runs when it's given a parameter. If we have a parameter with no argument, then we basically have a function that's not going to run. All right, I'm going to do a pull check. Do we understand that a parameter is a placeholder and it needs a value to be passed into it? Let me give another example. When you're, if you ever watch the Olympics, okay, and you see the marathon, well, not the marathon, but the track runners that are doing the relay, okay, relay racers, they need to receive the baton from the racer that's coming up behind them. And when they receive the baton, then they're racing, then they're running. If they start the race and they don't receive the baton from the other track runner on their team, and if they run to the finish line, it doesn't count, right? It doesn't matter if you win the race if you don't have the baton in your hand. It needs to be passed to you. So something needs to be passed to this guy, start num, in order for this function to actually do what it needs to do. Okay, so we gave it a value, we ran it, and it actually did the function call. What if we pass in an argument, but we have no parameter? Can someone give me a prediction for this? We're giving an argument, but we have no parameter.
It'll come out as 3.
Let's see it.
Oh, it's not defined.
Yeah. Yeah, it's not going to work. It needs to have something here to receive that 3. If we just start passing in values to our function, but our function is not expecting to receive those values, the function is going to flip. It's going to say, hold on a second. What do you want me to do with this 3? I don't know what this does. I don't know what this is. I can't deal with this. And it breaks down. So you need to have something there, some sort of value. All right. and it actually, yeah, here's a good example. If I don't spell it correctly, as I have it spelled in my function, then it's still not going to get passed. All right, let's run this just to see how a typo will work. It doesn't work. There's going to be a highlight somewhere in my code that says, could not find start num. Did you mean star num? And then you can click quick fix. But actually should be start. So I'll put start on both. Okay, now it should work. Yes, we did cover this week, but because we're not all 10s today, I feel like we have to cover it again. Make sure it's really in our understanding. Okay, we don't want to go on to our next stack and be confused by our function not running because it didn't receive a argument or parameter. Okay, so let's go ahead and continue on with the lesson. Functions, I think this is our thing that we need to study a little bit. It's not going to be on the test, but you're going to want to know it anyways. So it's not like an urgent need that you need to figure this out by tomorrow. We're really working on HTML, CSS, and JavaScript all together to work on our site for our test. But this you're going to want to know for your interview. So it's not like this is arbitrary information we're throwing your way. Okay. And I think we're over the hour in lecture material. I think this is where we stop. Let's take a look at Monday. Monday, we're going to be talking about how we can use JavaScript to manipulate the DOM. We can use JavaScript now to attack different parts of our HTML, change our HTML in some way. Okay, so we'll go ahead and end our lecture now. Again, we have code reviews available right after this lecture. We have one at 3 and we have 2 at 4. One's going to be in a room with me. Another one's going to be in a room with Vincent. Okay, it doesn't matter who you do yours with, but we have 2 groups at 4. So feel free to fill up this time slot and work with Vincent today. So you all should have access now to put your name and the assignment you want to have reviewed for your code review. Okay, so everyone should have their name on this part of the calendar. If you cannot add your name and project, please get a hold of me, drop in my room, send me a message, send me an email, get a hold of me somehow to get your name on here, because we have to get a code review in before Wednesday next week so you can take your test. All right, and then at 2, we are going to have a trivia party. Okay, not like celebrity trivia. We're going to have an actual JavaScript trivia party. It's not going to be like a tough group activity. It's going to be light. We'll keep it light today. So code reviews, you have a chance to catch up on assignments, something you worked on either Wednesday or Thursday, or get ahead on assignments, work on Monday or Tuesday's assignments. Okay, and if we have no further questions, we'll go ahead and end the lecture now. All right, let's go ahead and end it. Okay.